A tool can work perfectly on your server and still confuse an AI client. In this topic, we'll move beyond basic functionality and focus on clear intent, constrained actions, and reliable outcomes, so models can choose the right tool safely and consistently. We've already covered the MCP foundation, how servers fit into the model, how they run in production, and how access is secured. Now we move closer to the AI client's decision point, the tool interface. Our focus is reliability through clear schemas, safe side effects, predictable errors, manageable results, and testable behavior. Traditional API design assumes a developer reads the documentation and writes exact code against it. MCP tool design is different. The language model is often deciding which tool to use and how to call it. That makes names, descriptions, schemas, and examples part of the model's reasoning context. If a name is vague or a description is too broad, the model may choose the wrong action or invent invalid parameters. Strong tool design makes the intended use obvious, constrains inputs clearly, and helps the client act safely. The first production principle is simple. Tool names should tell the AI exactly what the tool does. A vague name like fetch data forces the model to guess. A stronger name combines an action with a domain and scope, like get invoice by ID or create customer. That clarity helps the client choose the right tool, avoid overloaded workflows, and take more reliable actions. Descriptions are more than human documentation. They are part of the model's decision system. A good description starts with the tool's plain purpose, then explains when to use it, when not to use it, what inputs or context are required, and any side effects or restrictions. Avoid promotional language like powerful or best in class. Use operational language the model can act on, precise, bounded, and testable. Clear boundaries are what keep a well-described tool from being misused. Tell the AI when the tool is allowed, what access is required, what inputs must already be known, and what limits apply. Make side effects explicit too. Is the tool read-only? Does it change data? Or could it perform an administrative or destructive action? These constraints help the client choose safely, avoid unauthorized calls, and set the right user expectations. In production, boundaries are not extra documentation. They are part of the contract. Examples are one of the best ways to prevent tool confusion. When two tools sound similar, the model needs concrete patterns. A broad request like find open billing tickets belongs to search tickets, while retrieve ticket 87,245 belongs to get ticket by ID. Counterexamples matter too. They teach the boundary. Don't use an ID lookup for filtering, dates, or keyword searches. Include realistic parameters because IDs, dates, enums, and filters are where ambiguity often turns into the wrong tool call. As an MCP catalog grows, ambiguity becomes a design problem, not just a writing problem. Two tools may both sound useful for the same request, especially when names and descriptions overlap. Help the client choose by making the selection rule explicit. Is this tool for a known ID, a search query, an owner, a status, or a workflow stage? You can also contrast tools directly. Use this instead of that when the user needs a report, not a task update. Clear domains and intent boundaries turn a crowded catalog into a reliable decision system. Granularity is a design choice, not a quality score. Small, focused tools give the model clear building blocks. They are easier to test, permission, observe, and recover from when one step fails. The trade-off is that the AI has to plan and sequence more actions. Larger workflow tools do the opposite. They package a known process, reduce planning overhead, and protect steps that must happen in order or atomically. But they can also hide decisions and side effects. Use fine-grained tools for exploration and workflow tools when reliability and control matter most. That granularity choice directly shapes how an agent plans. If every backend action is its own tiny tool, the agent may need long chains of calls. That adds latency, creates more failure points, and can make recovery harder. The opposite extreme is risky as well. One broad, all-in-one tool may blur permissions, hide important decisions, and reduce observability. The sweet spot is a tool that matches a real user intent and a stable backend operation, with clear inputs, outputs, and failure modes. Reliable composition starts by separating tools that find things from tools that change things. The model should search or retrieve first, receive a stable identifier, and then pass that identifier into the next call. Action tools should make preconditions and state changes explicit. Draft can become submitted, submitted can become approved. If a step requires confirmation, expose that as a tool or field, not as hidden knowledge. The goal is a predictable chain, where each result clearly enables the next safe action. Production. MCP tools should feel like business actions, not database knobs. Instead of exposing update order record and hoping the model infers refund policy, expose request or refund for order. The server can then check eligibility, permissions, limits, and audit requirements in one controlled place. This makes the tool easier for the AI to choose and safer for the organization to operate. Results should be outcome-oriented as well. Refunded, declined, partially completed, or waiting on a next step. Good tool design turns raw capability into a countable workflow. A good MCP tool makes the safe path obvious. Be skeptical of tools that accept open-ended instructions, such as raw SQL, shell commands, broad admin actions, or unrestricted search. These give the model high authority with very little guidance. During review, ask, what can this tool touch? What constraints are enforced? And what damage could one bad call cause? If the answer is too much, the interface is too broad. The pattern is to keep the capability but narrow the interface. Instead of raw SQL, offer named queries like search orders by customer or revenue summary. Instead of shell access, expose approved actions like restart service or get deployment logs. Admin work should become explicit operations, such as disable login or rotate API key. Search should require filters, pagination, and permission checks. These tools are easier to validate, log, test, and review. The model still helps users act, but it acts through guardrails designed for the task. Reliable MCP tools start with clarity, names, descriptions, constraints, and examples that help the model choose correctly. They also need the right granularity, safe boundaries, and purpose-built actions instead of broad, risky access. From here, we'll make those designs enforceable with schemas, validation, structured outputs, and later safe mutations, errors, pagination, and testing.